Okay, as promised, I'm going to record a video to help you with this work assignment number 2. This work assignment has to do with alcohols and ethers and corresponding reactions. So let's start with this first one. So this is an alcohol. So as a functional group, it's an alcohol because it has an OH. Now, go to your cheat sheet and look up alcohol. And you should always do this if you have any question about what the functional group is. Find it on the cheat sheet. So here's the basic structure of an alcohol. It's going to end in OH. And when you write its name, it's going to end in -ol. This example is ethanol. It's eth, 2 carbons, -ol, ethanol. Okay, so we see that this first compound is an alcohol. So it's going to end in -al. Okay, longest chain, 1, 2, 3, 1, 2, 3, 4. So that's going to be bute. So this is a butanol. We have to indicate where the OH is. It could be on this. So that's why we have to indicate where it is. So it's going to be on carbon number 1. So then the counting order is 1, 2, 3, 4. 1, 2, 3, 4. So we have to account for this substituent group, which is a methyl, and it's on carbon 2. So this is 2-methyl 1-butanol. Okay, so let's do this one. Now, it has an OH, but it has it's a special OH because it's bonded to an aromatic ring. So we're going to look this up on our cheat sheet, and we find out that this is a phenol. So it's a phenol. It's an OH bonded to an aromatic ring. It's going to end as phenol. Here's an example, 4-ethylphenol. So this is a phenol. So it's going to end in phenol. Now, this indicates that this is carbon 1, this is carbon 2. So this substituent group is isopropyl. We've had this before, and it's on 2, carbon number 2 of the phenol. So this is 2-isopropyl phenol. This is 2-isopropyl phenol. Okay, here's another alcohol. It's going to end in -ol. It's going to end in -ol. The longest carbon chain is 1, 2, 3, 4, 5. So it's a pent. But it's in a ring, so it's cyclo. So this is cyclopentanol. We have to indicate where the substituent group is here. It's a methyl. This is carbon 1, carbon 2. So this is 2-methyl. I'm going to have to write it up here. 2-methyl 2-methyl cyclopentanol. All right, now we look at this. This is an ether. So we go to our cheat sheet and find ether. Cheat sheet and find ether. Here it is. So here's an ether. An ether, the structure of an ether is an oxygen with carbon on either side. And ethers are always named as an alkane. The longest chain gets that alkane name. And the front part of it, the substituent group, is going to be an alkoxy. So here's an example. So here's the alkane, which is ethane, and it's a methyl group, so it's a methoxy. So this is methoxyethane. All right, so let's try this one. So it's an ether. It has oxygen with carbon on either side. The longest chain is 1, 2, 3, 4, 5, 6. 6 on 2. So it's 6. So this is, it's going to end in ane. 6, which is hex. Here is the substituent group, and it's on carbon 1, 2, 3, 1, 2, 3, and it's going to be on 3 whether we move in this direction or 1, 2, 3, 4. No, it would be 4. So it's 1, 2, 3. So this is going to be 3. This is ethyl, so it's ethoxy, hexane. 3-ethoxyhexane. Okay, let's go to this group. So this is also an ether, oxygen with carbon on either side. The longest chain is 3. So this is going to be a propane. And the substituent group is an ethoxy. And this ethoxy is bonded to carbon 3. Sorry, it's bonded to carbon 1. So this ethoxy is bonded to carbon 1 of 1, 2, 3. So it's going to be 1-ethoxy propane. This is 1-ethoxy propane. Okay, let's do this last one. It's also an ether. Oxygen, carbon on one side, carbon on the other side. This is a cyclopropyl. This is a propyl. So this is propane. This is cyclopropane. What do I name it? How do I name it? Do I name it as propane or cyclopropane? Well, as it turns out, cyclo compounds have precedence over non-cyclic alkyl groups. So it's going to be named, the parent name is going to be cyclopropane. And again, if you want to continue to write it backwards, that's fine. So this is single bond, so it's an ane. It's going to end in ane. 3 carbons is prop, so that's propane. It's cyclized, so that's cyclopropane. So here is the substituent group, and it's bonded to this, but we don't have to indicate a number because whether it's bonded to this carbon, this carbon, this carbon, it's going to be the same name. But we do have to indicate that this is the substituent group. The substituent group is carbon 1 because it could have been carbon 2. So this is going to be in parens 1 propoxy, 1 propoxy cyclopropane. 1 propoxy cyclopropane. Okay, good. We're done with the writing, naming the structures. Now let's go on to the reactions. Okay, complete the following reaction. H2SO4. So that's going to be acid. So if you look on your flashcards. That's going to be H+. This is going to be heat. It's an alcohol, so it's going to be, the type of reaction is dehydration. This is a dehydration reaction. In other words, we're going to remove water. There's an understood hydrogen group there. So the water we're going to remove is going to include this OH, so we're getting rid of that. And we're getting rid of that. That's water. And then we're going to move this bond into this location. So we end up with that plus H2O. Okay? Let's go to the next reaction. So this is an oxidation. So this is potassium permanganate, which is an oxidizing agent. So we're going to look at the oxidation of a secondary alcohol. And the oxidation of a secondary alcohol is going to give us a ketone. So we're going to actually lose 2 hydrogens. Here's one of the hydrogens. Here's another hydrogen that's understood but not shown. So we're going to get rid of this, get rid of this, and this bond is going to go there. So the answer is going to be 2, 3, 4, 5. That's the product. Okay. Here we have an alkene, and we're going to add water across this double bond, so that's a hydration reaction. It's a hydration reaction. And the OH gets attached to the carbon with the least number of hydrogens. So that's going to be, this has 1, that has 2. So the OH goes here. OH goes there. And the H part of water is going to go there. And we're going to get rid of one of these bonds. So the OH goes to that carbon, the H goes to this carbon. We're going to get rid of one of these bonds. And so the answer is going to be CH3, COH, CH2, CH3. Okay, here is an oxidation reaction because of that O, it's an oxidation reaction. So an oxidation reaction involves removing 2 hydrogens. Here's one of the hydrogens we're going to remove. And here's another one that is unseen in the line angle configuration of this drawing, but we're going to get rid of it. And its bond is going to go there. That bond is going to go there. So that's going to be 2, 3, 4. So we add water. Sorry, it's an oxidation, so we're going to get rid of 2 hydrogens. And this is the product. Okay, let's do this one. This is H plus, so H2SO4 is a strong acid, that's H plus. Here we have heat. So this is going to be a dehydration reaction. Dehydrate, removal of water, dehydration. Here's where the OH of the water comes from. Now we could pull off this hydrogen to complete the removal of water, or this hydrogen. And we pull off the one of the carbon with the least number of hydrogens. So this carbon has 2 hydrogens, this carbon has 1 hydrogen, so we're going to pull off this. And that bond is going to go there. So here is our answer. There's our answer. Okay, here's an oxidation. So we're going to remove hydrogens, 2 of them. Here's one of them we're going to remove. And here is the other one we're going to remove. So this is a line angle, so it normally won't show the hydrogens in the line angle, so we know that there is one there because it's 4 bonds to carbon. 1, 2, 3, 4. This 4th one is hydrogen. We're going to remove that, and its bond is going to go there. And last but not least, this is a dehydration, because H2SO4 is a strong acid and it's heated, and this is a dehydration. So we're going to remove water. I'm going to draw in the hydrogens. So we're definitely going to remove this, the OH, but which hydrogen are we going to remove? This one or this one? We're going to remove the one that is attached to the carbon with the least number of hydrogens. This has 2, this has 3, this has the least number of hydrogens, and so we're going to remove it. And its bond is going to go there. So this is 2, 3, 4, 5. That's where the bond goes. There you have it. Thank you.